Hey folks, Dr. Wu here. Today we are learning about velocity. I wanted to start off with this riddle. Let's say we have a racetrack, and let's say on the first track, the first go, you can walk as slow as you want. Let's call that V1. My question to you is, after you go around the first time, how fast do you need to go the second time in order for your average velocity, which is your average between the two laps, to be twice V1? So you're going around it the first time. How fast do you need to go the second time so that your average between the two is going to be twice your first original speed? Something to think about. If you know the solution, let me know in class. We can discuss it by the end of this lesson, and you'll get some Warrior dollars. Okay, let's talk about velocity. Velocity is given by this equation right here. V equals delta x over delta t. This delta x, this is change in position. And this is delta t, this is change in time. Let me just first say that all the equations that I write today, and I'll point out which ones are important, you can write down on that table of conversion card I gave you in class and use those on tests. So let me just first say that change in position, we're going to consider this basically how far a person travels. That's how far. Change in time is how much time has passed. So that might be seconds, that might be minutes. And this makes sense for us. Let me briefly touch upon speed versus velocity. We're going to use speed and velocity interchangeably in this class. However, they're not the same thing. And I do want you to have a basic understanding of the difference. Velocity is change in position. Sometimes this is referred to as displacement. If I go around a track and I'm starting here, and I go all the way around and end up at the same spot, I end up in the same position. My change in position, or my displacement, or my delta x, is actually 0. So no matter how fast I go around the track, my velocity will be 0 because my v is going to be 0 divided by t. No matter what the time is, my velocity will be 0. Speed, however, just refers to distance traveled. So in this track, let's say this track was 100 meters. Well, I would have 100 meters divided by my time, and my speed would be non-zero. Let's say my time were 2 seconds. Well, in the first example with velocity, my velocity would actually be 0 meters per second because I end up in the same place. But my speed, if I have 100 divided by 2 seconds, that's actually 50 meters per second. And that would be my speed. So we're not going to deal with any cases where somebody's going around a circular track and ending up in the same place. We're always going to be dealing with motion in one direction. So speed and displacement are going to be equal. And so from here on out, we will use speed and velocity interchangeably because their change in distance will always equal their change in position. There will always be the same thing in this class. So now that we know that they're basically the same thing, let's go ahead and take a look at the equations that we'll be using. Here are the equations. You're going to have velocity which is v equals x divided by t. And I'm going to remove the delta signs, which are these triangles, just to simplify it. We also need an equation for distance. Distance, which is going to be for us, x, is going to be v times t. Our final equation is time, and that's t, and it's going to be equal to x divided by v. You can write these three equations on the back of your unit table of conversion card. Let me just give you the units that we use for velocity, distance, and time. For velocity, our units are basically going to be meters per second. Sometimes we might have kilometers per hour, miles per hour, or other units of distance and time, but our main one is going to be meters per second. And so let me actually write the other ones down too. So miles per hour we might use kilometers per hour. We might occasionally use miles per second, kilometers per second too. What are the units for distance? Well, my units for distance are going to be meters, miles, and that's basically it. Maybe kilometers. Those are basically the units we'll see for distance. What about time? My units for time will be things like seconds, hours. Occasionally, you might see things like days or weeks, but seconds and hours and maybe minutes are our main units of time. So those are our three equations and their units. One way to help us remember these equations is this triangle right here. This is the velocity triangle. The way I read this is this line, horizontal line, is division. This means division. This line right here means multiplication. So if I want v, I know it's x divided by t. If I want x, I know it's v times t. If I want t, I know it's x divided by v. That's one way you can remember these three equations. Let's go ahead and apply these equations to some practice problems. It says a car is traveling 62.5 miles per hour. How far does it travel in 2.22 hours? Well, the first thing that I do is I notice it's asking how far. How far, that's the equation for distance. So my equation for distance is x equals v times t. And I just plug in. My v is 62.5 miles per hour. And I'm going to multiply. By the way, when I write this dot, that's the same thing as the multiplication symbol. Some people use x, some people use a dot. I will use a dot oftentimes. I multiply by my time, which is 2.22 hours. Notice that when I do velocity times time, I have hours here on top and hours on the bottom here, and they're going to cancel out when I multiply these. I put this into my calculator, 62.5 times 2.22, and that gives me 138.75 miles. That's my final unit. That's how far the car traveled. Using the same information, we're now asked how long does it take for it to travel 126 miles? Well, when it says how long, I know that's time. And my equation for time is going to be x divided by v. And so if I plug in x, I have 126 miles. That's my distance right here. I know that because it has the units of miles, so that's a distance. I divide by my velocity, which is 62.5 miles per hour. And if I divide this, 126 divided by 62.5, that gives me 2.016. Oftentimes, I will ask you, almost always, to round to 2 decimal places. So I only want to keep the 0 and the 1. This 6 is going to cause me to round up. So if I drop that 6, my 1 goes up to 2. What's my unit? Well, because it's how long and we're looking for time, I use the unit of time that I have in my problem, which is hours. That's the only unit of time that I have, and that's how long it would take to go 126 miles. But why is hours our unit? Why does that end up being our unit? Well, if I look here at the units, I have miles divided by miles per hour. That's what this is saying. Miles is on top. I divide it by miles per hour. Well, when I divide by something, that's the same thing as multiplying by its reciprocal, meaning I put, instead of miles on top, hours on the bottom, I put hours on top and miles on the bottom. Let me say that one more time, and I'll just show it to you again. If I divide by miles per hour, I can flip miles and hours around by putting hours and miles. I can flip them around by changing the division symbol to a multiplication symbol. And when I have miles on top and miles on the bottom, hours is my final unit. Multiplying allows me to cancel out these units. Let's do another example. It says a man is walking 4.78 meters per second. How far does he travel in 32.1 seconds? How far? That's x. That's the equation for x, which is v times t. And if I plug in, I have 4.78 meters per second. That's my v, times 32.1 seconds. That's my t. And if I multiply these two, that gives me 153.438. I'm going to round to 2 decimal places. This 8 is going to cause me to round up, so my 3 will become a 4. And my final unit, seconds cancels out, it's meters. And that makes sense because it's asking how far. How far? 153.44 meters. How long does it take for it to travel 105 meters? How long? That's the equation for time. And that's going to be x divided by v. And so if I have x, that's going to be 105 meters. This meters tells me it's an x. I divide by my velocity, which is right up here, is 4.78 meters per second. If I do 105 divided by 4.78, that gives me 21.9665. I only want to keep 2 decimal places. I look at this 6 here, even though there's a bunch of numbers. There's actually, if you were doing this in your calculator and following along, there's a lot more numbers here, but I only look at this number. And this 6 tells me I'm going to round up. If I round my 6 up, it's going to become a 7. I'm looking for a time, how long. My only unit of time is seconds, and that's what ends up being on top when meters cancels out. So my final answer is 21.97 seconds. Let's do one more example. A bird is flying 10.5 miles per hour. How far does it travel in 1.99 hours? Well, how far? What is it looking for? It's looking for x. What's my equation? That's v times t. What's v? This guy right here is v. What's t? This guy right here is t. And if I plug it in, just like those commercials, the air freshener commercials, plug it in, plug it in. If I plug it in, I get 10.5 times 1.99. That gives me 20.895, and I want to round to 2 decimal places. So I'm going to drop this 5, and it's going to cause me to round up. Well, what happens with 9 when I round it up? It becomes 10. And so this 8 also has to become a 9. 20.895 rounds up to 20.90. My final unit when hours cancel out are miles. How long does it take for it to travel 11.3 miles? Well, what equation is it looking for when it says how long? That's time. And my equation is x divided by v. Well, what is my x? This is my x right here. 11.3 miles. Miles tells me it's an x. How fast was he going? What was his v? Well, the bird was traveling 10.5 miles per hour. If I divide this, 11.3 divided by 10.5, that gives me 1.076 and a bunch of other numbers, but I only look at this number. And so I'm going to round up to 108. Miles cancels out. Hours is going to be on top. And that makes sense because it's asking for a time. It's 1.08 hours. Now, this is the second part that you need to answer that riddle, that as in terms of what I described at the beginning. It's the equation for velocity average. How do I figure out average velocity? If I'm driving and I speed up and slow down and then speed up and slow down, what's my average? Well, it's not as simple as adding up all my speeds and dividing them. It's not that simple. What I need to do to find my average velocity over the course of an entire trip is I take my total distance traveled, divide it by my total time. Again, if we were truly talking about velocity instead of distance, I would be saying displacement. And what that means is, for the problems that we're going to see, you're going to see different distances. So there's going to be a distance traveled, let's say x1, and a time that took. Let's call that t1. And then you're going to get another distance traveled. Let's call it x2. And then another time for that traveling. And let's call that t2. And so our total distance divided by total time is x1 plus x2. That's our total distance traveled divided by t1 plus t2. And that's our total time. And that gives me my average velocity. And my units here are going to be something like meters per second. Divided by, well, actually, the reason why that is because the units for x are meters and the units for t are seconds. And when I add up meters plus meters, the unit doesn't change. It gives me meters. When I add these, the x's and the t's, it doesn't change their units. And I end up with meters on top, seconds on the bottom. Let's take a look. A woman walks 5.2 miles in 2.46 hours at various speeds. She speeds up, she slows down. But what is her average velocity? Well, average velocity, remember, is total distance over total time. You should write this down in your formula sheet on the back of your table of conversions. Well, my total distance traveled is just 5.2 miles. I really don't care if she sped up or slowed down. My total time traveled is 2.46 hours. And so if I divide 5.2 divided by 2.46, that's 2.113 and a bunch of other numbers. I drop the 3 and round down to keep 2 decimal places. So it's just 2.11 miles per hour. Very easy. It was just x divided by t. Almost the same as the equation we saw earlier. But let's take a look here. It says a car travels 50.4 miles in 1.2 hours, then slows down and travels 34 miles in 1 hour. What was his average velocity? Well, that's hard to figure out, but not when we have our equation, which is total distance, which is x1 plus x2, divided by total time, which is t1 plus t2. And so this is my x1, and this is my x2. They have the units of miles. This is my t1, and this is my t2. So 50.4 plus 30 divided by 1.2 plus 1, that gives me 80.4 divided by 2.2. Notice that if I were to put this into the calculator, I need to put these in first to get my number 80.4, and then I need to put these in separately to get 2.2 and then divide them. Otherwise, if you were to just put 50.4 plus 30 divided by 1.2 plus 1, because of order of operations, it won't do it in this order right here. It will actually do this first and then add these numbers. And that's not what we want. So we need to put in the top, figure it out, put in the bottom. And when we do 80.4 divided by 2.2, that gives me 36.545. And I'm going to keep 2 decimal places. That 5 will cause me to round up to 5. And my final unit is going to be, well, I had miles. These are both miles on top, hours on the bottom. This is miles on top, hours on the bottom. So when I divide it out to one singular number, I keep these units. And it will be miles divided by hours. Even though I have one single number, I have miles per hour. Just as a brief side note, what does that mean? That means 36.55 miles in 1 hour. That's my velocity. In 1 hour, on average, I go 36.55 miles. And that is equal to, so these two things are equal, 36.55 miles per hour and 36.55 miles divided by 1 hour per 1 hour. I just oftentimes don't write the 1 on the bottom because if I divide something by 1, it stays the same. Let's see here. A woman walks 109 meters in 115 seconds, then walks another 200 meters in 205 seconds. What's her average? Well, that's easy for us. We take total distance, x1 plus x2, divided by total time. This is my x1, this is my x2. 109 plus 200. Divided by, this is my t1, and this is my t2. That's 115 plus 205. Now remember, I need to add the tops and then add the bottoms. So I will have 309 meters. These are both meters on top. And I will have it's 320 seconds on the bottom. These are both seconds. When I divide this out, 309 divided by 320, that gives me 0.965, but I round up. There's other numbers here, by the way, but there's a 6 here, but I only use this number to round. So I'm going to round up to 0.97, What are my units? I have meters on top, seconds on the bottom. They're not going anywhere. My units are meters per second. What this means is for every 1 second, this woman walks 0.97 meters. This is our last one. Let's take a look. A bird flies 12 miles in 0.78 hours, then flies 15 miles in 1.66 hours. What is its average velocity? What's my formula for average velocity? That's x1 plus x2, total distance, divided by total time. Which one's x1? That's x1. Which one's x2? That's x2. Which one's t1? Which one's t2? So I do 12 plus 15. I'm plugging it in, divided by 0.78 plus 1.66. That gives me 27 on top. I need to do it first. Then I need to do the bottom. 0.78 plus 1.66 is 2.44. And this is miles on top, hours on the bottom. And if I divide 27 by 2.44, that gives me 11.07 when I round up miles per hour. That's my average velocity, and miles per hour makes sense because we're talking about a velocity. That's basically it. There's some practice provided for you on Schoology. We will also be practicing in class. So good luck. I'll be able to answer questions, but go ahead and give it a shot by yourself.